LeetCode Problem number 416, partition equal subset sum. So this question gives us an integer array called nums, and we have to return true if we can partition the array into two subsets such that the sum of the elements in both subsets is equal. Otherwise, we have to return false. So what this means is, let's say it gives us nums equals 1, 5, 11, 5. So we know that we can partition this into 1, 5, 5, and the total would be 11, right? And the remaining subset would be 11 itself, making this array returning true because both subsets in this case can be partitioned to have equal values. Now if you look at this another example, 1, 2, 3, 5, we can easily tell it's false because if we were to add all of this up, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 5 is 11, and since 11 is not an even number, we can just immediately return false in this case. But let's say if we have a number that is, for example, 2, 4, and 4, since if we were to add this up, this would give us a total of 10, and by right it should be divisible by 2, right, since 10 is an even number. But if you look at our array, we cannot subset it in a way to have 5 each, right? It's always 6 or 4. Knowing this, things first, I have the total sum here. So this total sum will, as the name implies, will basically get the total number of all the integers inside the array, right? For this case, let's say our num is, let's try a small number, like 1, 2, and 3, right? So in this case, the total num would be 6, right? And the half of it would be 6 divided by 2, which is 3, right? So by right, if the total sum, in this case just now I mentioned, if 6 is not divisible by 2, what we have to do is to just immediately return false because there's no way we can partition it to have even numbers in both subsets. But since this case it is divisible by 2, since its total sum is 6, so we're good to go. Now here I'm using a interesting approach called the bit set, right? So what I'm doing is for every number given, what I'll do is I'll store its occurrence inside the bit set, and when everything is done, all I need to do is return the half value inside of the dynamic programming. And if it exists, if there is a 1, it means that we can create the half using numbers inside the subset, right? Okay, so let me explain what I mean. Let's say dp is now 1, right? So the way bit set works is, since here I have a bit set of 100,000, 10,000, so by right it will have like a lot of zeros in front of it, right? But for this case, I'll simplify it down, so I'll ignore the zeros at the back, but do remember that there are zeros at the back, right? But since I'm using 1 over here, so basically you can treat it as like an integer, but it's only 1s and 0, right? So for every number, so right now the num is 1. So let's take a look at what is happening over here. So dp equals to dp, and this is the 4. And here I am pushing dp with nums. Okay, let's break this down first, right? So this would equals to 1 and push by 1 time, right? So what this means is, let's say since dp was 1, so by doing this, by pushing 1 time, meaning that I'm adding a 0 in front of it, right? So technically this would mean 10, right? But in this case, obviously, since this is a bitwise, in number terms it will mean 2, right? But anyways, this is 10. We're not interested in the number, we're interested in the position of the 1s and 0s in this case. This is 10, and we are just doing a OR of dp and 10 itself. So if you remember, dp was 1, right, meaning that there's a existing 0 in front of it. So if we were to do an OR, dp will now become 1 1, right, because OR takes in, as long as there's a 1, it will take in the 1, right? So that's how it works. So let's continue. Now that dp becomes 11, or in this case 1 1, now we'll iterate through. So the next number we have 2. So again, this will basically mean shift by 2, and since we are shifting dp by 2, so it will be 11 shifted by 2, meaning adding 2 zeros. Remember 11 here, adding 2 zeros, and then we are doing the OR operation. So this would mean having the 2 extra 0 in front of it with the 11, right? So in this case, it will look like this. So dp will have 4 1. Okay. Next, num is 3. So same thing. We push it 3 times. So this will have 3 zeros in front, behind it. And then we are doing the OR operation again. Like this, right? So this would basically give us, right, 1 1 1 from here. This will basically give us all ones, right? So what this means is that, so what we have here is basically mean from 0 to 6. From 0 to 6, we are able to create numbers from 0 to 6 using the numbers given to us over here, right? So 1 we can create obviously with 1, 2 we can create with 2, 3 we can create with 1 and 2, 4 we can create with 1 and 3, and the list goes on until we have 6, right? But in this case, we are only interested to know whether or not we can create the half of it, which is 3. And if you look, 0, 1, 2, 3, since everything is 1 here, this is true, meaning that we can create 3, right? Meaning that we can split this into an equal partition. Right? Okay, so let me show you an example where it's not possible to split into an equal partition. For in this case, 2, 4, 4. Okay, so total sum we know from it is 10. Half of it will be 5. And since 10 is divisible by 2, so this will not return false. If this were to be, I don't know, let's say 3, for example, then this will give us 9. And 9, we cannot, there's no way for us to split it into 2, right? Because to split it into 2 subsets, meaning that we will need both subsets, we will need the whole number to be an even number so that we can actually split it into 2. Right? Okay, so the half of it would be 5. Right, 6 plus 4, 10 divided by 2 is 5. And dp starting from 1, our num currently is at 2. So let's start fresh. So we are pushing it 2 bits. So 1, adding 2 zeros here. So now we have the OR operation against 1 itself. Right. So right now, with 0, 0, 1, right, the 1 was from the original dp itself, and the 100 is from the from this. Okay, so we get 101. Okay. Alright, so next we have 4. So we have to push 101 4 bits, adding 4 zeros, and again 101 itself. Right, so we pad it with the zeros in front of it. So again, using OR operation, we will get this number. Next up is another 4. So we are going to shift this 4 bytes. Again, against this. Okay, so we use the OR operation, this will get replaced as well. Right. Okay, so what we have here is basically whether or not we can split into all subsets, right? So starting from 0, we can split 0 to 0 because technically there's nothing. We can just return anything. But for 1, we can't create 1, right? Because there's no 1 here. For 2, we can, since there's a 2 itself. For 3, we can't. There's nothing here we can add to 3. For 3, we can't. 4, we can, obviously. 5, we can't. 6, we can, because there's 2 and 4. 7, we can't. 8, we can, because there's 4 and 4. 9, we can't. And 10, we can as well, right? Because 6 plus 4 will get us 10. But since we are only interested in the half, which is 5, and looking at this, 0, 1, 2, 3, 4, 5, we cannot create a subset of with a total of 5, since there are no numbers here that gives us that option basically. Okay, so basically that's how it works. That's why I chose to use the bitset method to do this. Anyways, that's all I have to show. Thanks.